Hey everyone, let's just jump right in. Welcome to this explainer. We're kicking off episode 1 of our 6-part series, Prompt to Product Engineering with AI. Now look, today is all about the foundation. We're laying out a completely modular AI stack, and honestly, we aren't going to write a single line of code today. If you're a developer who has messed around with AI assistants, maybe used them here and there, but you've never actually wired them together into a true, reliable engineering pipeline, well, you are in exactly the right place.
All right, so let's start with the real problem here. If you've used AI, you've absolutely felt the temptation to just drop this exact phrase into a prompt box. Build me an e-commerce app. I mean, it feels right, doesn't it? Let the AI do the heavy lifting. But look, this is a massive trap, and we as developers need to stop falling into it. Asking an AI for an entire project in one single shot, you're basically just setting yourself up for a nightmare.
Because when you hit enter on that giant prompt, what you get back is what we call the wall of output problem. It's just this massive monolithic block of code. There's no design system, absolutely zero consistency, and the worst part? It is completely unreviewable. You have no idea what crazy assumptions the AI made under the hood, and there's just no way to isolate where things actually went off the rails. It's totally unmanageable.
So here is our core thesis for this whole series. We have to stop looking for one omnipotent, magical tool that just does everything. That tool doesn't exist. Instead, we need to build a real engineering pipeline where every single component does exactly one job and it does it incredibly well. The real leverage, the actual productivity gain with AI, comes from investing your attention in the clean handoffs between these specialized tools. So let's look at the very first tool in that pipeline.
Tool number 1 is without a doubt the most underrated tool in the entire stack. It's the prompt itself. Before we even think about software, we have to talk about the prompt, because it literally dictates the quality of your entire final product. Treat it like a real engineering artifact. A vague prompt, you're going to get generic, useless output. But a precise, opinionated prompt gives you a coherent, actually buildable result.
When you put a giant prompt up against staged prompts, the difference is just night and day. We already know the giant prompt fails, but staged prompts, they split a massive goal into a sequence of small, highly reviewable stages. You can actually verify stage 1 before stage 2 even starts, catching bugs when they are super cheap to fix. And by throwing in a shared context block, a set of global rules and naming conventions, you make sure every single stage stays perfectly consistent.
Okay, moving on to our reasoning layer, Claude. In this stack, we aren't really using Claude to just churn out raw code. It's doing the heavy thinking. Claude is at its absolute best where human-level judgment is required. And in our pipeline, it actually tackles 2 very distinct judgment jobs, one at the very start and one right at the very end.
So Claude's first job happens right at the beginning. It can take a super short statement of intent, like literally just a few sentences saying you want a premium beauty app, and expand that into a precise, structured 39-stage design specification. Going from a rough idea to a rigorous spec, that takes deep judgment. Claude fills in all the blanks for the design system and the UX logic before we even think about building anything.
Then we have Claude's second job, hanging out at the very end of our pipeline. This is Claude Code, and it runs directly inside your terminal, living right in your project folder. Its whole job here is translating those completed designs into real application code, file by file. Translating a visual design into well-structured modular code? Again, that requires serious judgment, which is exactly why Claude is booking both ends of our workflow.
All right, so once we have that rock-solid specification, we need the third piece of our stack, Google Stitch. This is a really cool AI design tool straight out of Google Labs, and its one and only job is to take those plain language descriptions Claude just wrote and turn them into real, high-fidelity UI. Layouts, components, typography, Stitch completely owns the visual design side, keeping our workload perfectly segregated. But here's why Stitch is absolutely vital to this specific stack. Listen to this, because it's a huge paradigm shift. If your design tool just spits out a flat picture, your coding agent literally has to look at a screenshot and just guess the margins, the colors, the layouts. But Stitch doesn't do that. It outputs structured HTML, CSS, and actual design tokens. Because the output is structured data, your coding agent can actually read and parse it directly later on. It's a total game changer.
In practice, Stitch's high-fidelity output looks incredible. But what matters most is that under the hood, it is totally semantic. All those specific spacing rules, the exact color hex codes, the typography scales, they're cleanly structured. It essentially hands you an exact blueprint that is 100% ready for a coding agent to ingest.
Okay, so we've got structured designs generated by Stitch, And we've got Claude Code waiting patiently in our terminal. But how do we actually pass these complex designs over to Claude without losing all that precious detail in translation? Well, that brings us to tool number 4, our connection layer, MCP. MCP stands for Model Context Protocol. The easiest way to think about it, it's basically a universal USB-C adapter for AI. It lets an AI assistant, like Claude, talk directly to an outside tool, like Stitch, in real time. Without MCP, you're stuck manually exporting HTML, copying and pasting design tokens, just constantly shuffling context windows. And every manual handoff, you lose critical detail. MCP just completely eliminates that friction. All right, the final piece of the stack, agent skills. Look, if we want our pipeline to pump out consistent results every single time, we absolutely cannot rely on our own memory to enforce the rules. Skills are basically reusable instruction files that a coding agent reads automatically. Think of them as the ultimate conversion rulebook for your agent as it turns those designs into actual code. Now, it's really important to distinguish between two specific types of rules here. You have a global context file, like a CLAUDE.md file, which loads with every single prompt. Those are your absolute, unbending global rules, like always use TypeScript. But a domain agent skill? That only loads when a specific workflow actually comes up. By isolating these workflows into skills, we ensure that the 30th screen of our app is built to the exact same rigorous standard as the second screen. So, there they are, our 5 tools: prompts, Claude, Stitch, MCP, and skills. Now let's take a step back. We've got all our individual ingredients, so let's look at the recipe. How do these actually assemble into a cohesive, repeatable engineering pipeline? Let's walk through this concrete 6-step workflow. Ready? Step 1, you write a short request. Step 2, Claude expands it into a massive stage specification. Step 3, Google Stitch takes that spec and generates a structured design. Step 4, MCP handles the seamless handoff, no copy-pasting allowed. Step 5, Claude Code, using agent skills, converts it into real application code. And finally, step 6, you, the human engineer, review and commit the code. I'm telling you, the true value here is entirely in those clean handoffs between the distinct stages.
Now, before we wrap up this foundation, we need to do a quick reality check. I want to have a very grounding, honest conversation about the actual limitations of this AI stack. It's so vital to set proper engineering expectations here, so you don't go into this expecting pure magic.
Here are the hard limitations you need to know. First off, this is not a one-click magic button. You have to manually review things at every stage. Second, the design-to-code conversion, it's not strictly pixel perfect because code generation just isn't perfectly deterministic yet. Third, a generated design only ever shows the happy path. You still have to actively design your loading states, your empty states, and your errors. And finally, and most importantly, this absolutely does not replace knowing how to engineer software. You can only review code as well as you understand it. The AI accelerates your typing, guys, not your baseline judgment.
So I'm going to leave you with a bit of a provocative question. We established early on that highly specific staged prompts are the best way to get quality output, right? But building a complex app requires a massive 39-stage specification. Who actually wants to sit down and write that massive document?
Well, the answer is you don't. Coming up in episode 2, we are finally going to start building, and you'll see that Claude actually writes the master prompt for us. We just give it 3 sentences, and it generates the entire 39-stage blueprint. Honestly, it's the single most surprising part of this entire workflow, and you definitely won't want to miss seeing this pipeline start running. Thanks for hanging out with me for this explainer, and I'll see you in episode 2.